my channel Science and Math with Gerard. Today we will be continuing with a chapter that we started, ratio and proportion, and today we will be doing the further practice set in half. As you know, I have been dividing the practice sets in half so that you don't start getting bored, as the practice sets are quite lengthy. So today we will be doing the first half of practice set 4.3. In this practice set we will be seeing the first 3 questions in today. So let us see what exactly are we supposed to do. In the previous video I explained to you all 5 different operations of equal ratios. What are we supposed to do with equal ratios, and we saw 5 different operations. Today we will be actually applying these operations in this practice set. So let us begin. First question in the practice set is a upon b is equal to 7 upon 3 and find the following ratios. To find the following ratios, first thing that we are given is a upon b is equal to 7 upon 3. A upon b is equal to 7 upon 3. This is what we are given, and what we are supposed to find is the first thing that we are supposed to find is 5a plus 3b upon 5a minus 3b. So for that, first thing that I am supposed to find is 5a plus 3b upon 5a minus 3b is equal to question mark. This is what I am supposed to find. Now let us consider what we are given. So a upon b is equal to 7 upon 3. This we already have, right? So now what I will do is I will multiply both sides by 5 upon 3. Why did I multiply both sides by 5 upon 3? You can see a has the number 5 and b has the number 3. So if I multiply a by 5, I get 5a, and if I multiply b by 3, I get 3b, which is what I require. Hence, not only on the first side, but whatever I do on the left hand side of the ratio happens to the right hand side of the ratio. So multiplying both sides by 5 upon 3, I get 5 upon 3 multiplied by a upon b is equal to 5 upon 3 multiplied by 7 upon 3. Solving all this, I get 5a upon 3b is equal to 35 upon 9. This is what I have for now. Now, if you observe the equation that we are supposed to find, you can see numerator plus denominator and numerator minus denominator, which is what, therefore, what we have to do is by componendo dividendo we get. So we will do componendo and dividendo to this ratio, and now what we have is 5a plus 3b upon 5a minus 3b is equal to 35 plus 9 upon 35 minus 9. Hence, the final answer that I get is the same is equal to 35 plus 9 is 44 divided by 26, which you can further divide by 2 and get 22 upon 30. So my final answer that I got from all of these is 22 upon 30. This is how I found the first sub-question in the first question of this practice set. Second question, 2a square plus 3b square upon 2a square minus 3b square. Again we will do what we have already. A upon b is equal to 7 upon 3. Now first thing that there is not a upon b, but we are supposed to find a squared and b squared. So squaring both sides, a squared and b squared we require, that is why we have to square both the sides. That is why a squared upon b squared is equal to 7 square upon 3 square. Calculating all of this, a squared upon b squared is equal to 7 squared upon, not 7 squared, answer will be 49 upon 9. This I have now. Now you can see a squared, that is numerator, has 2 and denominator, that is b squared, has 3. So multiplying by 2 upon 3 on both sides. So multiplying by 2 upon 3 on both sides, I will get 2a squared upon 3b squared is equal to 2 into 49 upon 3 into 9. Now I can find the answers, that is 2 into 49 is 98 and 3 into 9 is 27. This is the new ratio that is formed. And to find 2a square plus 3b square and 2a square minus 3b square, what we have to do is component. As simple as that it gets. Therefore, by componendo dividendo, 2a square plus 3b square divided by 2a square minus 3b square is equal to 98 plus 27 divided by 98 minus 27, which will give me 98. On adding 27 I get 125, and 98 minus 27 will give me 71. This is my answer for the question, sub question 2 of the first question. Similarly, third one can be done by only dividendo, and fourth one is also similar to the first one, hence we can find the fourth one as well. Now question number 2 of the practice set. Here we are given, second one tells us 15a square plus 4b square upon 15a square minus 4b square. So second main question is 15a square plus 4b square divided by 15a square minus 4b square is equal to 47 divided by 7. This is given to us, and the first thing that they are asked to bring that into simple form, that is a upon b. So we have to bring this part into the simple form a upon b. First one is to find a upon b. For that we already have it in the form componendo and dividendo. So again we will do componendo and dividendo to bring that in simple form. This is the logic that we are supposed to use. If componendo and dividendo is already given, again use the same property to find the answer. So first again we will do by componendo and dividendo. I will get 15a square plus 4b square plus 15a square minus 4b square divided by 15a square plus 4b square minus 15a square, and minus and here minus, that is why plus 4b square is equal to 47 plus 7 divided by 47 minus 7. Here I have the componendo and dividendo, and if you can observe, I can cancel some terms in this. So plus 4b minus and plus 15a minus 15a square. These are the numbers that get cancelled, and what I am left with is 15 plus 15 is 30a square upon 8b squared is equal to 47 plus 7 54 divided by 47 minus 7 is 40. These are the numbers that I got. I have to get a upon b. Here I have a squared and 30a squared 8b squared. So first I will remove these numbers, that I have to take these numbers on the other side, and for that a squared upon b squared is equal to 54 upon 40, and denominator is 8. When it goes on the other side, it gets in the numerator, and numerator goes to the denominator. This is what I got for the question. 8 ones are 8, 8 fives are 40, 6 fives are 30, and 6 nines are 54. Therefore, a squared upon b squared is equal to 9 ones are 9, and 5 into 5 is 20. Here I have the values of 9a squared upon b squared, but what I am supposed to find is a upon b, and for that simplest thing that I can do is taking square root. So taking square root. Therefore a upon b is equal to 3 upon 25. 9, not 25. 3 upon 5. 9 is the square of 3 and 25 is the square of 5. This is how I got the simplest form for this question, a upon b. Now moving on to the further part in this question, they have asked us to find 7a minus 3b and 7a plus 3b, and the further questions are also same. For now, we'll do the fourth sub question in this question. When I do the fourth one, you will automatically understand the second and the third one. Now let us see the fourth sub question after we have found the basic value of a upon b, that is 3 upon 5. So here, if I solve the fourth sub question, you will automatically be able to solve the second and the third sub question. So let us see what we are supposed to find in the fourth sub question. In the fourth sub question, we are supposed to find b cube minus 2a cube upon b cube plus 2a cube. This is what we are supposed to find, and what I have is actually a upon b is equal to 3 upon 5. First thing that we will do is I want b in the start, so b should be in the numerator. Therefore, by invertendo b upon a is equal to 5 upon 3. I just inverted both the ratios in the given question. Now I have b upon a is equal to 5 upon 3, and the next thing that I want is cubes. So the next thing that I will go is by taking cube on both sides. Therefore, when I have to take the cubes, it will be b cube upon a cube equal to 125 upon 27, as 5 cube is 125 and 3 cube is 27. This is how I found the cubes. Next, 2 in the denominator, therefore multiplying by 1 upon 2 on both sides. Now I have 1 upon 2 on both sides, therefore b cube upon a cube multiplied by 2 in the denominator. I will get 1 upon 125 multiplied 2 into 27, which is equal to 125 divided by 54. Now I have the values of b cube upon 2a cube is 125 upon 54. Now for the final step, second final step is, you can see type of componendo, invertendo, dividendo. Therefore, by componendo, dividendo, I will have the values as b cube minus 2a cube divided by b cube plus 2a cube, plus, and this will be minus, is equal to 125 plus 54 divided by 125 minus 54. I have plus and minus and plus. So again invertendo. By invertendo, I will have b cube minus 2a cube upon b cube plus 2a cube is equal to, subtraction of these two, 125 minus 54 will give me 71. Addition of these two will give me 179. This is my final answer for the question. Now to move on to the third and the final question for today's video is question number 3 of practice set 4.3. Please go through the question as I erase my board. Question number 3. If 3a plus 7b upon 3a minus 7b is equal to 4 upon 3. 3a plus 7b divided by 3a minus 7b is equal to 4 upon 3. And to find, I have to find 3a squared minus 7b squared upon 3a squared plus 7b squared. Now I am given some numbers and I have to bring them and to find this value. First basic thing that we do is bring this thing in basic form, that is this form should be brought to simple a upon b type of thing. So for that, let's start. As I told you earlier, when I look and I see it is a component to dividendo, I solve it again by componendo and dividendo. Therefore, by componendo dividendo, I will get 3a plus 7b plus 3a plus minus 7b divided by 3a plus 7b minus 3a plus 7b. Minus sign gets converted to plus because dividendo has subtraction in between them, and 4 plus 3 divided by 4 minus 3. The answers for this equation will get 7b and 7b will get cancelled, 3a and 3a will get cancelled. Now I have 6a, that is 3a plus 3a, 6a upon 14b is equal to 7 upon 1. This is what I have for the question. Now I will be transferring this as a upon b is equal to 7 multiplied by 14 divided by 1 multiplied by 6. Numerator goes to denominator, denominator goes to numerator, which is equal to 98 upon 6. Now I have the values of a upon b, that is 98 upon 6. Final. Next, I will have to calculate this number into this number, and this number has a square and b square. So this I will have to square. Taking the square, I will have a upon b squared upon square is equal to 98 squared divided by 6 squared. This is what I have. Now my answer for this will be 9604 divided by 36. Now how exactly did I do this 98 square? Now this is a trick, and this trick I will be explaining in the upcoming videos very soon. I have some tricks where I can calculate the numbers quite fast, may it be square, may it be multiplication, may it be addition or subtraction. And squares can also be found by simple addition and subtraction method as well. So stay tuned to the channel to find some more such interesting tricks. 98 square is 9604 and 6 square is 36. Now let's see what we can do ahead with this. A and b squared I already have. Now next numbers are 3 and 7. So multiplying by 3 upon 7 on both sides. So now multiplying by 3 upon 7 on both sides, I will get 3 upon 7 into a squared upon b squared is equal to 3 upon 7 multiplied by 9604 divided by 36. Let's see if I have any cancellations to do. I have 3 ones and 3 into 12 as my cancellation. Next is I have 7 ones and here I will cancel some numbers. I will get 7 ones are 7, 7 3s are 21, 5 and 0, 7 7s are 14 and 1 and 4, 7 2s are 14. So if you do a division, you will get the answer for 7 divided by 9604. I have 1372. 3a squared upon 7b squared is equal to 1372 upon 12. Now the fun part is, let's see what we are supposed to find. Therefore, by componendo dividendo, 3a squared plus 7b squared divided by 3a squared minus 7b squared is equal to 1372 plus 12 upon 1372 minus 12. Getting it? I'll get same number is equal to 1372 plus 12, that is 84, and 1372, that is 1360. Finally, we'll be dividing these two numbers by 2. So dividing the numbers by 2, I'll get 2 6 are 12, 1 and 8 9 are 2, 692, and here I will get 680, which can also be further divided by 2 again. So by 2 I get 3 9s are 80, and 396 divided by dividing by 2 I get 340. The fun part is this number can also be divided by 2, and we'll be going on dividing till we get a simple number. So let us see what we can do with this now. Let us divide it by not 2, but we'll move on to the next number, that is we'll divide this number by 4 and check if we can divide it. So 4 into 9 is 36, and again 9, so 36 I get divided by 4, and the next number that I will get is 4 8s are 32 and 85. Now this number cannot be divided further, and therefore my value of 3a plus and 3a square minus is this, but I want minus upon plus. So final step of the equation, invertendo. So 3a squared minus 7b squared upon 3a squared plus 7b squared is equal to 85 upon 90. This is the end of question number 3. Next video I will solve question number 4. First question, second, third, and the fifth one. The rest, the 2 questions that remain, that is question number 4 and 6, you will automatically understand on how they are supposed to be solved. Now, as I told you in the previous video, I will also be explaining to you all one trick of multiplication, that multiplying any number by 100 or 11 or 111. How we can find the number by not actually multiplying the numbers and getting the answer by just addition of some numbers. Let us see how that can be done at the end of the video. For now, we will start with our practice sets question number 4. The first sub question in practice sets question number 4 is x squared plus 2lx minus 20 divided by 3x minus 5 is equal to x squared plus 8x plus 12 divided by 4x, not 4x, 2x plus 3. This is what we have in the question. Now observe the question. See the numbers and what is the relation that we can find between the numbers. If you see, here is the number 12. When multiplied by or divided by 4, I will get 3. So 3 multiplied by 4 is 12. Similarly, 5 multiplied by 4 is 20. On the other hand, 2 multiplied by 4 is 8, and 3 multiplied by 4 is 12. This is how we find the relation. So when I multiply 4 in the denominator, I will automatically get a few numbers from the numerator. Let's see what we can do. First thing I will bring is multiplying both sides by 1 upon 4, as I have to just multiply that in the denominator, hence I did it as 1 upon 4. What I get is 1 upon 4 multiplied by x squared plus 12x minus 20 divided by 3x minus 20. 3x minus 5 is equal to 1 upon 4 multiplied by x square plus 8x plus 12 divided by 2x plus 3. Now actually multiplying the numbers in the denominator, I will get x square plus 12x minus 20 divided by 12x minus 20 equal to x square plus 8x plus 12 divided by 8x plus 12. 4 getting multiplied by 3x into minus 5 and 4 getting multiplied to 2x plus 3. This is what we have for the equation. Now when I do dividendo on this thing, I can know that I can subtract this minus this in the numerator, and when I subtract these two values, these 4 values will get cancelled. Similarly on this side 4 values will get cancelled. So by dividendo I will write x squared plus 12x minus 20 minus 12x plus 20 divided by 12x minus 20. When I subtract, my signs change, so plus 12x became minus 12x, minus 20 became plus 20. Similarly on the other side also, x squared plus 8x plus 12 minus 8x minus 12 upon 8x plus 12. So denominator will remain as they are, and now for cancellations I can do 12x minus 20 plus 20. Similarly 8x minus 8x, 12 and minus 12. Now what I am left with is x squared upon 12x minus 20 is equal to x squared upon 8x minus 12 plus 12. This is what I am left with. Now in both the denominators I have x squared, so that can also get cancelled. So x squared and x squared gets cancelled, and I am left with 1 and 1 instead. So the new thing that is formed is 1 upon 12x minus 20 is equal to 1 upon 8x plus 12. Now simple cross multiplication on equal ratios, I will get 8x plus 12 is equal to 12x minus 20. I just cross multiplied these numbers. In 6th standard we studied about bringing like terms together, and here I will bring them together. 8x minus 12x is equal to minus 20 plus minus 12. This is what I get. 8 minus 12 is minus 4x is equal to minus 32. Minus minus gets cancelled. X is equal to 32 divided by 4. X is equal to 8. This is my answer for question number 1 of practice set, sub question 1 from practice set 4.3's fourth question. Similar to this is the second one. Just a hint of change, and this is what we will find out when we solve the second practice set. Question number 2, sub question 2's question number 4 is 10x squared plus 15x plus 63 divided by 5x squared minus 25 plus 12 is equal to 2x plus 3 upon x minus 5. This is what I have in the second question. If you compare it to the first one, you will see both the simple ratios are this side. So now I will do first thing that I am bring in the form similar to the first question, that is by invertendo. What was not by invertendo, but it will be by alternando. What was alternando? The denominator of first ratio gets swapped by the numerator of the second ratio. So I have 10x squared plus 15x plus 63 divided by 2x plus 3, and this will go on this side 5x squared minus 25x plus 12 upon x minus. Now comparing the numerator and denominators on the both sides and finding the similarities. In the first question we found similarities between these two numbers. But now we will not, as you can see 2 and 15 cannot be made similar. So for that we will have to compare the first term. So 2 when multiplied by 5x, 2x into 5x will give me 10x squared, and 3 into 5x will give me 15x. X into 5x, 5x squared, and 5 into 5x, 25x. Hence this is how we will multiply by 1 upon 5x. Multiplying by 1 upon 5x. So 10x squared plus 15x plus 63 into 1 upon 5x multiplied by 2x plus 3 is equal to 1 upon 5x multiplied by 5x squared minus 25x plus 12 divided by x minus 5. Multiplying by 5x, I have the numbers as 10x squared plus 15x plus 63 divided by 10x squared plus 15x is equal to 5x squared minus 25x plus 12 divided by 5x squared minus 5. Now I can do the dividendo as we did in the previous sum, and similar type of sum will get solved. Let's see what we can do. By dividendo we will get 10x squared plus 15x plus 63 minus 10x squared minus 15x divided by 10x squared plus 15x is equal to 5x squared minus 25x plus 12 minus 5x squared plus 25x upon 5x squared minus 25x. This is what we got. Now cancelling all the equal numbers, I am left with 63 divided by, removing 5x common from this, that is again dividing the numbers 5x, I will get 5x into 2x plus 3 is equal to, here I have the number 12 divided by 5x into x minus 5. In the previous sum we cancelled the numerators. Now I have denominator equals, so 5x and 5x will also get cancelled. And last I have the numbers 63 divided by 2x plus 3 and 12 divided by x minus 5. By doing simple cross multiplications, we have 63 into x minus 5 and 12 into 2x plus 3. Calculating the numbers, 63x minus 63 into 5, I will get 315 is equal to 24x plus 36. Shifting the like terms together, I have 63x minus 24x is equal to 36 plus 315. Minus and plus, plus and minus. So subtracting these two, I got, when I subtract these two, I get 39x is equal to, and adding these two, I will get 351. X is equal to 351 divided by 39. X is equal to 39 nines is 351. With this, I got the second question ka answer for question number 4's second sub question. Now, time for the third. Third sub question is 2x plus 1 the whole square plus 2x minus 1 the whole square divided by 2x plus 1 the whole square minus 2x minus 1 the whole square is equal to 17 upon 8. Now the first two questions had some different logic. Now time for the third one. If you see, these two terms are in the form componendo and dividendo, and to solve, as you know, we have done it previously, we will do componendo and dividendo again. So by componendo dividendo, I have 2x plus 1 squared plus 2x minus 1 squared plus 2x plus 1 squared minus 2x minus 1 squared divided by 2x plus 1 squared plus 2x minus 1 squared minus 2x plus 1 squared plus 2x minus 1 squared is equal to 17 plus 8 and 17 minus 8. This is what we have. Now, as you know, in the numerator, first and third term and denominator, second and fourth term gets cancelled, as we have done many similar sums. So when I cancel all this, I have, sorry, I did a mistake. In the numerator, I will be cancelling the second and the fourth term. And in the denominator, I will cancel first and the third term. This is how it happens. It was a mistake from my side. So I have 2 times 2x plus 1 divided by 2 times 2x minus 1 is equal to 17 plus 8 is 25. 17 minus 8 is 9. 2 in the numerator and denominator also gets cancelled. Now I can cross multiply these values. Sorry, I had a square on both the places. So now taking square root. Square root of these two numbers will bring them to normal, 2x plus 1 upon 2x minus 1. And 25 square root is 5 and 9 square root is 3. Now I brought everything in simple form, just a simple cross multiplication. 2x plus 1 will be multiplied by 3 and 5 is multiplied by 2x minus 6x plus 3 is equal to 10x minus 5. I have 6x minus 10x. 10x goes to the other side, so 6x minus 10x is equal to minus 5, which is already here, and 3 will go on this side, so it will be minus 3. So minus 4x is equal to minus 8. Minus minus gets cancelled. 4x is equal to 8. X is equal to 2. This is the answer for my third sub question in question number 4 of practice set 4.3. Now for the fifth sub question of the same question. Another new logic that comes up. Now I have been solving 4 different questions because every sum that I am solving has a new logic. Now this sum that I had solved is similar to the fourth one. Just here and there we had square, and there we will have square root, and the sixth one we will have cubes. So we will have to take, as we took at the end cube square root, we will have to take cube root. Okay, the 3 sums are quite similar. I am just solving a new logic sum. Question number 5. Four x plus 1 squared plus 2x plus 3 squared divided by 4x squared plus 12x plus 9 is equal to 61 upon 36. And here I will show something new. How can we substitute this and this denominator numerator? How can we cancel it as we have been doing in the previous sums? So 4x plus 1 squared plus 2x plus 3 squared. This is my numerator, and here I will write the right hand side. If you see, 4x means 2x the whole square plus 12 means 2 into 2x into 3 and 9 means 3 square. So I have this equation as the form of 2a is a square plus 2ab plus b square. So this will be equal to a plus b the whole square. It is in the form a squared plus 2 multiplied by a into b plus b square, which gets converted to a plus b the whole square. And numerator will remain same, 4x minus 1 plus 1 plus 2x plus 3 squared is equal to 61 upon 36. Now numerator is single, denominators we have in component form, so we will have to convert this component form into a single term, and for that we will do the exact opposite of componendo, that is by dividendo. By dividendo, I have 4x plus 1 squared plus 2x plus 3 squared minus 2x plus 3 squared upon 2x plus 3 squared is equal to 61 minus 36 upon 36. 2x plus 3 squared minus 2x plus 3 squared gets cancelled, and I am left with the numbers 4x plus 1 squared divided by 2x plus 3 squared is equal to 61 minus 36 is 25 upon denominator is the same, that is 36. Now as I have squared and I have to bring it in simple form, I will do square. So taking square root, I have the values 4x plus 1 upon 2x plus 3 is equal to square root of 25 is 5 and square root of 36 is 6. Now I have brought the numbers in simple forms. Now final step, as we have been doing in every sum, cross multiplication. So 6 into 4x plus 1 and 5 into 2x plus 3. 6 into 4, 24x plus 6 is equal to 10x plus 15. 24x minus 10x is equal to 15 plus minus 9. 6. These are the numbers that I have got by bringing like terms together. 24 minus 10 will give me 14x is equal to 24 minus 10 will give me 14, and x minus 15 minus 6 will give me 9. Therefore, the value of x is equal to 9 upon 14. That is the end of practice set 4.3. Now, welcome to my channel Science and Math with Jerome. Today we will be continuing with the chapter that we have already started a few videos ago, that is ratio and proportion. And today the property that we will be visiting is the theorem on equal ratio, and this property is very interesting if you actually take focus and to understand this chapter and this property. So let us see what exactly does this property tell. The property tells you on page number 71 of the textbook, you can see if A upon B is equal to C upon D, that if I have two equal ratios, then A plus B upon, sorry, A not A plus B, it will be A plus C upon B plus D will be equal to both the ratios. What does this tell us? If I have two equal ratios, and if I add the numerator to numerator and denominator to denominator of both the ratios, still the new ratio that will be found will be equal to both the ratios. That is, it will be equal to A upon B, as well as the same addition will be equal to C upon D as well. This is what the property is all about. This is what we have in the property, and this property, that is theorem on equal ratios, will be applying this theorem in the practice set 4.4. So let us begin with our practice set 4.4. The first question in the practice set is fill in the blanks type of questions where you will find some interesting things about the question. What is it giving us? I have if first one x upon 7 is equal to y upon 3. This is what I am given, and is equal to, what am I supposed to find, is equal to 3x plus 5y upon dash is equal to 7x minus 9y upon dash. This is what I actually have. I am given the question. This is the first sub question of my main question, that is x upon 7 is equal to y upon 3. Now I have the two ratios. Now as I told you, it can be addition or it can be subtraction or it can be any other sign in this theorem on equal ratios, which means on two equal ratios I can add, subtract, multiply, divide, any property I can use on those two equal ratios. Still the ratios will be equal to the original ratios that is given. So new ratio will always be equal. Now coming to the question, what am I supposed to find? First I am finding 3x plus 5y upon dash. Now this is what I have supposed to find. For that, what I will see is, I can see that x is there right here and the number associated with x is 3. So I will have to multiply 3 to the numerator and denominator of the given ratio for x. Therefore x upon y is equal to 3 into x upon 3 into y. Also not x upon y, it will be x upon 7 is equal to 3 into x upon 3 into 7, which will give me 3x upon 21. 3 7 is 21. And further I will be finding out similarly for y. Now y is multiplied by 5, therefore y upon 3 is equal to 5 into y upon 5 multiplied by 3, which will give me 5 y is a 5y and 5 into 3 will give me 50. Now I have both these ratios, the new ratios that are formed, and I just have to add these ratios. Therefore 3x plus 5y upon what will I have? 21 plus 15. The original ratios were x upon 7 is equal to y upon 3 is equal to this, which is equal to 3x plus 5y upon 15 plus 21 will give me 36. This is the first half of my first sub question. Similarly, as I multiplied, similarly I will be multiplying over here. So x upon 7 is equal to y upon 3 is equal to 7x minus 9y upon 7 into x has the number 7. So 7 into 7. As numerator is 7, I have to multiply it by 7. And similarly 9 multiplied by the number is 3, which will give me 7x minus 9y that I already have in the numerator divided by 49 minus 27, which will be equal to 7x minus 9y divided by 49 minus 21 will give me to 27 will give me 22. This is the first sub question of the first question of practice set 4.4. Now moving on to the second sub question of the practice set first sum, that is I have a upon 3, b upon 4 and c upon 7. So my second sub question has a upon 3 is equal to b upon 4 is equal to c upon 7. I have three different equal ratios where I have to find the first thing that I am supposed to find is a minus 2b plus 3c upon what. And the next thing that I am supposed to find is something upon 6 plus 8 plus 14. Sorry, 6 minus 8 plus 14. This is what I am supposed to find for the second sub question. So let us see. As you can see, a upon 3 is equal to b upon 4 is equal to c upon 7 gives me my numerator is a minus 2b plus 3c. It gets very simple just write what numbers are given below the number. So A has the number 3. The sign should be same. Minus 2 multiplied by B has the number 4. Plus the sign will be remaining same. And 3 multiplied by C has the number 7. So respective to the numerator, I will have to write the denominator. So my numbers are A minus 2B plus 3C divided by 3 minus 8 plus 21, which will give me the value of A minus 2B plus 3C upon 3 minus 8 plus 21 will give me 16. This is what I have for the first part of this sub-question. Now second part, the denominator I am given A upon 3 is equal to B upon 4 is equal to C upon 7, and I have the denominator 6 minus 8 plus 14. This is what I have in the denominator, which is equal to the denominator 2 into 3 minus 2 into 4 plus 2 into 7. Why did I do 2 into 2 into 2 into? Because I had to bring the numbers 3, 4 and 7, which makes the numerator, which changes the numerator. 3 has the number A, numerator A, and multiplied by 2. Similarly, 4 has the number B multiplied by 2, and 7 has the number C multiplied by 2. So everywhere 2 is multiplied, and minus and plus. This will give me my answer 2B, 2A minus 2B plus 2C divided by 6 minus 8 plus 14. 6 plus 14 is 20, minus 8 is 12. This is what I have for my answer. This is the end of first sub-question of the practice set. Now let us see what we have to do in the second question of the practice set 4.1. 5m minus n is equal to 3m plus 4m. Then find the values of following expression. Five m minus n is equal to, what do we have? 3m plus 4m. And I am supposed to find the first value of m square plus n squared upon m square minus n squared, and second value I am supposed to find is 3m plus 4n upon 3m minus 4m. This is what I am supposed to find. Now, if you actually see this kind of sum, we have already done in the previous exercise. Similar sums are here. First thing that I have is the given equations. 5m minus n is equal to 3m plus 4n. Bringing them into like terms together, I have 5m, 3n will go here, is equal to 4n plus n. 2m is equal to 4 plus 1 will be 5n. m upon n will be 5 upon 2. The ratios have been formed. Now I have the value of m upon n. Now I need m square and n square. So squaring both sides, I have m squared plus n squared is equal to 5 squared will be 25 and 2 squared will be 4. This, when we found out, we already imagined that these are the type of sums that we did in the previous exercise. So now m squared upon n squared is there. If you see plus and minus, therefore by componendo dividendo, as we saw the first whole exercise, this also comes with componendo and dividendo. Therefore m squared plus n squared divided by n squared minus n squared is equal to 25 plus 4 and 25 minus 4, which is equal to 29 upon 21. This is my answer for the question second's first part. Now to the second part. I have the values of m upon n is equal to 5 upon 2 for the second part. This was the value of the first part. Now you can see m is associated with 3 and n is associated with 4. Therefore, multiplying by 3 upon 4 on both sides. Why 3 upon 4? 3m numerator, 4n denominator. So 3 upon 4. 3 upon 4 multiplied by m upon n is equal to 3 upon 4 multiplied by 5 upon 2. This is what I have. Again, 3m plus upon 4n is equal to 15 upon 8. Now, by what will I do? You can see 3m upon 4n here, 3m plus 4n and 3m minus 4n. Therefore, by componendo dividendo, 3m plus 4n upon 3m minus 4n is equal to 15 plus 8, 15 minus 8, which will give me 23 upon 7. This is the second question of the practice set 4.4. Now moving to the third questions. Now the interesting part is, according to the government's rule, half of this practice set is reduced from the portion for the exam. So now the remaining exercise, I only have first and second sub question of this practice set, question number 3. Question number 3 is the remaining 3 questions, that is question 3, 4 and 5, and main question 4 has been reduced from the portion. So we will be doing only the first 2 sub questions of this practice set question number 3. So let us see what we have in question number 3. I will clear the board till then. Question number 3 of practice set 4.4, first sub question. Let us see what we have. We are given, what do we have in the question? I have a y plus z is equal to b z plus x is equal to c x plus y. This is what I have given. A, B, C are not, the two are not equal, and I have to prove y minus z upon a, b minus c, which is equal to z minus x into b, c minus a, is equal to x minus y upon c, a minus b. This is what I have to prove. That is, to prove that y minus z, a into b minus c means ab minus ac, which is equal to z minus x into bc minus ab, is equal to x minus y into ac minus bc. This is what I actually want to find out. Now let's see what we can do with the question given. A y plus z is equal to b, z plus x is equal to c, x plus y. Now if you observe the question and the answer that I want, you will see that magically I get the numbers a, b and c. If I have a, I want b and c. If I have b, I want c and a. If I have c, I want a and c. Therefore, what I will do and how you understand this is multiply, divide each ratio by ABC. Dividing each ratio by ABC. This is how I will be solving it. So dividing everything by ABC, I will get a y plus z divided by ABC is equal to b z plus x divided by ABC into c x plus y divided by ABC. all three terms that I get is A, B, C. Now simple, you can see cancellations that are A and A, B and B, C and C. Everywhere I got a cancellation, and as you know, I did not want any ABC in the numerator. Everything from the numerator with ABC has gone, and all these ratios y plus z upon BC is equal to z plus x upon AC is equal to x plus y upon AB are remaining. Now all three are my equal ratios, and you can see I have single terms in the denominator. So if I want subtraction as we did in the first one, the first subtraction that I want is AB minus AC. So what do I have? AB minus AC. So first I will consider, let all these ratios be equal to K. There may be one more ratio that is equal to this. This is what theorem of equal ratios means. All these ratios are equal to one other ratio, that is K. So I want AB minus AC. Where is AB? AB is right here and AC is over here. Therefore, x plus y minus AC, therefore minus z, plus and minus, therefore minus x upon AB minus AC is equal to K. Here plus x and minus x will get cancelled, and what I am left with is K is equal to y minus z upon AB minus AC. Similarly, we will take another ratio where I want the second term as BC minus AC. So BC is right here, AC is over here, BC and AC is here. So I have K is equal to y plus z minus x upon BC minus AC, which is equal to, now plus z and minus z will cancel, and y minus x upon BC minus AC. This is the second. Now I have this, I will mark it as 1, this I will mark it as 2, and last K is equal to, what do I want in the final? AC minus BC. So I have AC here and BC over here. So z plus x minus y plus minus z divided by BC, not BC, I want AC minus BC. No. What do I actually want in this is let's see if I did any mistake over here. X plus z, y plus z. So this ratio that we found, I have named it as 1. So let us see the next ratio. Next ratio will also be equal to K, and in the second part I want BC minus AB. So where is BC? I have BC here and AB here. So let us see y plus z minus x minus y upon BC minus AB, which is equal to y, and y getting cancelled. I am left with z minus x upon BC minus AB. This is what I have in the second ratio, and this I will name it as 2. Naming the third one, K is equal to, now I am left with AC minus BC, that is AC minus BC. Therefore, z plus x minus y minus z upon AC minus BC. Z and Z again gets cancelled, and I am left with x minus y upon AC minus BC, equation 3. So from all the three equations that I found out, that is from 1, 2 and 3, I have K is equal to y minus z upon AB minus AC is equal to z minus x upon BC minus AB is equal to x minus y upon AC minus BC. Hence proved. Therefore, this is what we wanted over here. So all three ratios being equal to K means all three ratios are equal. This is what we had to prove, and we have proved it. Now to the last sub question of the practice set that we are supposed to solve. For that, again I will be raising the board and you read the question. So for the last question, sub question in this practice set that we are supposed to solve is x upon 3x minus y minus z is equal to y divided by 3y minus z minus x is equal to z upon 3z minus y minus x minus y. This is what we have given, and what we have to prove is all three ratios. To prove all ratios is equal to 1. The value of the ratio is 1. This is what we have to prove, and for that, first thing that we'll do is let x upon 3x minus y minus z is equal to y upon 3y minus z minus x is equal to z upon 3z minus x minus y equal to k. So if I want all ratios equal to k, which means that k I want be equal to 1. My final answer, if k is equal to 1, then all the ratios are equal to 1, as all ratios are taken equal to k. Now adding all the ratios, I have x plus y plus z. I added all the numerator, which means I have to add all the denominators. So 3x minus y minus z plus 3y minus z minus x minus 3z minus x minus y is equal to k. This is what I have. So numerator remains as it is, x plus y plus z upon 3x minus x minus x. So 3x minus 2x will give me x. 3y minus y, 3y and minus y, which will give me plus y, because plus 3y and minus 2y will give me y. And similarly, plus 3z minus 2z, z and z will give me z is equal to k. Now numerator and denominator get cancelled, therefore k is equal to 1. Hence all my given ratios are equal to 1. That is the end of practice set 4.4. Tomorrow on the next video we will be seeing the new property, that is continued proportion, and last practice set of the chapter, practice set 4.5. Stay tuned to my channel for more such videos. Thank you.